Welcome to Learn with Roblox. In today's video, we're going to cover how to find the vertex of any parabola, so let's get right into it. In this first problem, we have that y equals 3 times x minus 3 squared plus 7. We need to recognize that this is in vertex form. What is a vertex form? It goes something like this. Y is equal to a times x minus h squared plus k. And what you need to know about vertex form is that the vertex is simply written as h, comma k. In other words, what you do is you flip the number inside of the parentheses to get h from minus h, and whatever number on the outside, that plus k, you just keep it as it is. So let's think about how we can apply that to this problem to find the vertex. So first, you take the number inside the parentheses, that's minus 3, and you flip its sign to make it plus 3. And then for the number on the outside, k, you just keep it as it is. So plus 7 stays as 7. So in other words, our vertex for this equation is just 3, 7. That was pretty easy. Here, we need to find the vertex of y equals 0.5 times x plus 10 squared minus 18. Once again, this equation is in vertex form, and let me write that again. So vertex form is y equals a times x minus h squared plus k. And the vertex is derived from flipping the number inside the parentheses, that minus h becomes a plus h, and this k just stays as k for the vertex. So let's apply that to this problem. You have to flip the number inside the parentheses. So plus 10 actually gives us an x-coordinate of minus 10 for our vertex. And then the k value on the outside, that's minus 18, you just keep it as it is. So our vertex for this problem is minus 10, minus 18. Let's go on to some harder examples. In this problem, we have that y is equal to 3x squared minus 18x plus 10, and we need to find its vertex. So notice that this equation is written in standard form. What is standard form? It's when a quadratic equation is written as y equals a times x squared plus bx plus c. Now how do I find the vertex from this? Here's what you need to do. You first need to apply a formula. You need to do minus b divided by 2a. And this gives you the x-coordinate of the vertex. And then what you need to do is, you need to plug in that x-coordinate back into the equation to find the y-coordinate. Let's try and apply this to this problem. So first, let's find the x-coordinate using minus b over 2a, where b and a are the coefficients in this equation. So if I do that, minus 18, that's my b, and this 3 is my a. And just for reference, this plus 10 is our c, but we will not be needing that. So let's do this. Minus b over 2a. So if we do that, minus b is minus negative 18. And then 2a is 2 times 3, which is 6. Minus 18 is just plus 18. And then 18 divided by 6 is just 3. So the x-coordinate is just 3. And to find the y-coordinate, we just need to plug in 3 into the equation. So let's do that. We're going to have 3 times 3 squared minus 18 times 3 plus 10. If we do that, 3 times 3 times 3 is just 27, that's 3 cubed. 18 times 3 is 54, so minus 54. And then add 10. And if you do all of this, you'll get minus 17 as your answer. That is your y-coordinate. So therefore, the vertex of this equation is 3, minus 17. Let's go on to the next one. In this problem, we need to find the vertex of the equation y equals x squared minus 3x plus 7. Whenever you have an equation in standard form, you need to find the x-coordinate first, and you do that by doing minus b over 2a, where a and b are the coefficients in this equation. Let's identify what a and b are. So a is the coefficient on the x squared term, and notice that's just 1, because x squared is the same thing as 1x squared. So 1 is our a. And then b is the coefficient on the x term, and notice that's just minus 3. Now let's apply minus b over 2a. So minus b is minus 3 divided by 2a, and 2 times 1 is just 2. And minus 3 is just positive 3 because two negatives cancel when you multiply them. So our vertex is 3 divided by 2, which is 1.5. So we know that's our x-coordinate. Let me write that. So 1.5 is our x-coordinate of the vertex, but how do I find the y-coordinate? Well, all you need to do is plug in this 1.5 back into the equation and solve for y. So let me erase some of this here. And let's plug in 1.5. So the y-coordinate will be equal to 1 times 1.5 squared minus 3 times 1.5 plus 7. Let me step out of the way here. And then 1.5 squared is 2.25. 3 times 1.5 is 4.5, so minus 4.5. And then you add a 7. And then if you do all of this, 2.25 minus 4.5 plus 7, you will get this is equal to 4.75. So that's our y-coordinate. So let me go down here and fill this in. Our vertex is going to be 1.5, comma 4.75. And that's it. This problem says, find the maximum value of the equation y equals minus 2x squared minus 10x minus 21. What in the world does that mean? How do you find the maximum value of this equation? Let's think about that for a minute. I want you to know that this is in standard form first because it's ax squared plus bx plus c, and our a value of minus 2, that's a negative number. So in other words, this parabola is a downwards facing parabola. I want you to imagine that for a minute. A downwards facing parabola, what does that look like? Let me sketch one out. It probably looks something like that. And then where do you think the maximum value of this parabola is going to be? Well, it's right at the top. It's right here. But what's that point? That point is the vertex of this parabola. So this is something that the SAT really likes to do. Anytime you see minimum or maximum of a parabola in a problem, they usually want you to find the vertex of the parabola. So let's do that now. All we need to do is find the vertex in this parabola. So to find the vertex, you use minus b over 2a anytime you have an equation in standard form. Our a is minus 2, our b is just minus 10. So let's apply this formula. Minus b is minus 10. That is a positive 10. And then 2a is 2 times negative 2. That's just negative 4. And then 10 divided by negative 4 is negative 2.5. So this is the x-coordinate. We need to plug that x-coordinate in to get the y-coordinate. So let's do that. So first I'm going to just write a note here that our vertex is going to be minus 2.5. And then we need to find the mystery y value. So let's do that. Let's plug in minus 2.5. So we're going to have minus 2 times 2.5, or minus 2.5 squared, minus 10 times negative 2.5, minus 21. So let's evaluate this. Minus 2 times minus 2.5 squared, you can just put this into a calculator. And what you're going to find is that it's equal to negative 12.5. And then minus 10 times minus 2.5, that just becomes positive 25. And then we still have a minus 21. And then if you evaluate all of this, you'll find that this is equal to negative 8.5. So that is the y value of our vertex. So now let me fill this in. Our vertex is minus 2.5, comma, minus 8.5. And then when it wants the maximum value of this function, that is just the y-coordinate. So our actual answer is just 8.5. And just like that, we're done with this problem. In this problem, we need to find the vertex of y equals x squared plus 4ax minus 10 and write it in terms of a. So notice this is in standard form because it's ax squared plus bx plus c. And let's identify what those coefficients are. So our a value, that's just a 1 because x squared is the same as saying 1x squared. So 1 is our a. And then for b, be careful. This whole 4a over here, that's our b value because that's the total coefficient on x squared. So that's b. And then minus 10 is our c value, but that will not be important in this problem as you'll see. So to find the vertex of this parabola, this is in standard form, so apply the formula minus b over 2a. If we do that, minus b is just minus 4a. And then 2a is just 2 times 1, which is just 2. And then minus 4a divided by 2 is just minus 2a. So this is our x-coordinate. When you have the x-coordinate, you can just plug it back into the equation to find the y-coordinate of the vertex. So let me do that. I'm just going to erase a bunch of stuff here. And now let's evaluate this. We'll have y is equal to minus 2a squared plus 4a times minus 2a minus 10. Minus 2a squared, that's just minus 2 squared times a squared. And minus 2 squared is just positive 4 because the minuses cancel. So you have 4a squared plus, and then 4a times minus 2a is just negative 8a squared. And then you have a minus 10. And then 4a squared plus negative 8a squared, that's just minus 4a squared. So this is our y-coordinate. So now let's write the total vertex now. So our vertex is minus 2a. That was our x-coordinate that we got from doing minus b over 2a. And then when we plug that back into the equation, we got that the y-coordinate of the vertex was minus 4a squared minus 10. And just like that, we have found the vertex in terms of a. Let's go to the next one. Here we need to find the vertex of the equation y equals 2 times x minus 2 times x plus 4. To do this, we need to recognize that this equation is in intercept form. You know it's in intercept form because it has been factored into two binomials. And let me just quickly review what intercept form is and why it's important. Intercept form is a quadratic in the form of y equals a times x minus p and then x minus q. And what's so special about this form? What you know is that the x-intercepts are at p and q. Let me just write that, x-intercepts. So basically, you flip the number inside the parentheses to get the x-intercepts. Okay, how can we use that to get the vertex? Because I just told you how to get the intercepts, but that's not the vertex. That doesn't seem very useful. Well, let me do this first. First, let's find the x-intercepts of this equation. To find the x-intercepts, you just flip the numbers inside the parentheses. Minus 2 turns into a plus 2. Plus 4 turns into a minus 4. Now, let me just sketch this parabola really quick. So we have a parabola with an x-intercept of plus 2. And maybe minus 4 is over here. And you know that this parabola is facing upwards. How do I know that? The a value, that 2, is positive. So the parabola, if it points upwards, it probably looks something like that, maybe. And then that means the vertex would be down here. What do you notice about the vertex in relation to the x-intercepts? Notice that the x-coordinate of that vertex, it's halfway between those x-intercepts. So I draw this here. This is just the axis of symmetry, or the x-coordinate of the vertex. It's halfway between those intercepts. So all we need to do is, to find the x-coordinate of this vertex, we just need to find the number that is between 2 and minus 4. How do you find the number that is between two other numbers? To do that, you simply take the average of those numbers. To take an average, just add up those numbers and divide by 2. So 2 plus minus 4 divided by 2, that's just minus 2 over 2, which equals negative 1. So I've just found the x-coordinate of this vertex is just minus 1. And then now you can just plug it back into the equation to get the y-coordinate of this vertex. So let's plug that in. We have 2 times minus 1 minus 2 times minus 1 plus 4. And this is just equal to 2 times minus 1 minus 2 is minus 3. Minus 1 plus 4 is just positive 3. And then 2 times negative 3 is negative 6. Negative 6 times 3 is just 18. So this just equals 18. Or sorry, it should be negative 18. And that's the y-coordinate of the vertex. So I found that the vertex of this parabola is just minus 1, comma, minus 18. And just like that, we're done. In this problem, we need to find the minimum of the parabola with the equation y equals 3 times x minus 10 times x plus 2. To do that, let's think about what the minimum of a parabola is. I know that this parabola is going to face upwards. Why? Because that value on the outside, 3, is positive. So just imagine a parabola that faces upwards. Oops, that's a very poorly drawn parabola. Let me do that again. And where's the minimum value? It's right down here. And what's that point? Is the vertex. So once again, as I said earlier, the SDA really likes to do this. Whenever we see minimum or maximum value of a parabola, they're just asking about the vertex, really. So let's find the vertex of this parabola. To do that, what I'm going to do is, because this is an intercept form, because it has been factored, we can find the x-intercepts. To do that, just take the number inside the parentheses and flip it. So our x-intercepts are just going to be minus 10 turns into a plus 10, and then plus 2 turns into a minus 2. And then what do you do with those x-intercepts? What you know is that the vertex is located halfway between those x-intercepts. Let me just sketch a picture for you again. So plus 10 is maybe over here, minus 2 is maybe down there, or over there, and this parabola faces upwards. So maybe it looks something like that. And notice that the vertex, its x-coordinate is halfway between those values. So what you need to do is take the average of those x-intercepts. That gives you the x-coordinate of the vertex of the parabola. So to do that, you do 10 minus 2 divided by 2. I'm just adding up those x-intercepts. That just equals 8 over 2, which is just 4. So 4 is the x-coordinate of this parabola. And then once you have 4, you can just plug it back into this equation. So I'll have y is equal to 3 times 4 minus 10, and then times 4 plus 2. Okay, well that equals 3 times 4 minus 10 is minus 6. 4 plus 2 is just positive 6. And then if you put it into a calculator, minus 3, or 3 times minus 6 times 6, that is just negative 108. So that is the y-coordinate of our vertex. So therefore, our vertex is just 4, negative 108. But be careful, that's not what the problem actually wants. This problem asked for the minimum value. The minimum value is the y-coordinate. Therefore, our answer is 108. And just like that, we're done. In this final problem, we need to find the vertex of the equation y equals minus 1 times x minus a times x plus a, and express that vertex in terms of a. Because this is an intercept form, you know that is an intercept form because it has been factored. Let's find the intercepts first. The intercepts are just found by just taking the number inside the parentheses and flipping them. So x minus a, that gives you an intercept of a. Because I just flipped that minus a into an a. And then here, x plus a, you flip that plus a into a minus a. So these are our x-intercepts. They're a and minus a. And now imagine this. If I plot this, let's say positive a is over here, and negative a is over there. Where do you think the vertex is going to be? It's going to be right in the middle of those intercepts. But if I have a and then minus a, what's in the middle of those? Well, those are just the same number with a different sign. Therefore, if you take the average of those numbers, or find what number is in the middle of them, that's just going to be at 0. So in other words, the x-coordinate of the vertex is just 0. So our vertex is in the form of 0, something. And what I need to do is I need to plug in 0 into the equation to find what the y value of this vertex is. So let me just do that. So I'm just going to plug in 0 into this equation. So I have 0, or minus 1 times 0 minus a times 0 plus a. Okay, well those zeros are kind of redundant because we're just left with minus a and plus a. So I have minus 1 times minus a times plus a, or positive a. Minus 1 times minus a is positive a. Positive a times positive a is just a squared. So this whole thing just becomes a squared. And just like that, we found the y-coordinate of the vertex. So let me just fill this in down here. Our vertex is just 0, a squared. that's it, we're done. If you enjoyed this video, please consider leaving a like and subscribing. Thank you for watching.